Welcome to the Control Engineering webcast, 5 Keys to Successfully Digitalizing Your OT Data Infrastructure, sponsored by Matricon. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering. Here are some tips to get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with the audio or the slide presentation, click on the question mark at the top right corner of the screen to adjust the volume on the webcast platform. Any problems with the audio or slide presentation, click on the question mark at the top right corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Type questions for our speaker in the Ask a Question box on the left side of the screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of the screen. Those documents also will be available with the on-demand version of the webcast. I'm happy to introduce today's presenter, Derek Komanek. As Senior Consulting Manager at Matricon, Derek works with vendors and end users alike to help unlock the business value of data in their assets via OPC UA. Derek works frequently with the OPC Foundation to help evangelize OPC UA by presenting it on globally and publishing articles about the technology and its advantages in the IoT Industry 4.0 M2M worlds. For the past 15 years, Derek has played various roles in Matricon and Honeywell, including sales, marketing communications, product manager, strategic marketing. Before joining Matricon, Derek worked as a professional software engineer with Hewlett-Packard, GE, and ran his own software consulting business. Derek is a professional engineer with a Bachelor of Science in Computer Engineering from University of Alberta. Now I'll hand it off to Derek. Please go ahead.
Great. Thanks, Mark. So hello, everybody. Welcome to this presentation on what we call the 5 keys to digitalization. So the concepts that I'm going to focus on here are data connectivity, context management of information that percolates throughout the organization, how you traverse networks, data federation, how you bring information together as you're going from the shop floor up throughout the enterprise, and then eventually also for cloud integration. Now, before diving into the different details, I think it's worth taking a step back and looking conceptually at what's involved and what happens when you set out to digitalize your business. So in the slide, I put a few layers together, right? You've got your shop floor, you've got your operations, there's the business layer, and now we've got the cloud layer. And the thing is, all of these need to utilize the same type of information for different purposes. Now, originally, the systems that you have on the shop floor aren't necessarily designed with in mind for sharing with the rest of the enterprise. They're designed to run on your PCN, your process control network, and manage the actual operations of what's being produced or the services. So as we go up that stack, the different applications each have their own purpose, and as you start to mix it, in order for all of them to communicate at the same time, you need them to share information in context that each next level requires, whether going up or down. However, that is not, they don't all upgrade at the same rate, right? So systems that you have on the shop floor, they're installed. These systems will run for sometimes 20, 30, 40 years. So they have a certain way of generating information, certain tolerances for how much information can be requested from them before they destabilize, etc. And then as you go up that stack, I mean, the changes happen quicker. You know, we're all getting used to sort of the online updates. If you guys have any of the obviously online applications, they're getting updated all the time, sort of in the back end as you continue to use, you know, the applications, whatever you're working on. So the tolerance and the ability to change and cycle through different versions changes quite dramatically as you move to the different levels in an organization. Now, what that means is that if you are trying to do system digitalization, where you're bringing in data from the shop floor and you're utilizing it throughout the enterprise in a secure way, and you want to make that sustainable so it's not a one-off type solution, you need something that will actually allow all these components to exist or to continue to run in their own native environments, but at the same time be able to share the information with either systems above or below them in the stack, right? So this is where we come in, and the term that I've coined is the unified OT data layer. And the idea there is to bring all the information that's available at the shop floor or the OT data network, to make that available in a way that's digestible or usable at all the other levels, including throughout the OT network itself, because there are also, you know, security issues and compatibility questions that happen also between components, obviously, on the shop floor. So UODL, the idea is how do you build that type of infrastructure, let's say, arrangement that allows all this information to be shared equally. Now, once you have this sort of chassis where the information from the OT data networks is available throughout in whatever format that you need it in, then everything can kind of start to move together. And therefore, you don't have the, you know, dramatic toppling slide that I just showed, but basically more everything operates the way it did, but together it actually moves forward. And that's where you can start to then realize the benefits of digitalizing, you know, the organization, and it's done in a sustainable way. Now, conceptually, that's what we're going to be talking about, of how do you build such a thing, and something that we call data technology for building that. But if we step back and say, okay, well, now let's go back sort of to reality. Most organizations are still based on a Purdue network model, right? So you've got the different layers firewalled off from each other. Different components sit at every level. OT sits below, let's say, the DMZ. Then you climb above the DMZ into, you know, your IT space, which is basically the business network. And then above that, we go off into the cloud. Now, with that, there are a number of question marks that start to show up on that journey, and it goes in both directions, as far as how you handle some of these aspects. So whether that is, you know, connectivity down to the actual components themselves, pulling the information together, moving across the OT space, or the operations network, or beyond that across firewalls and out into the business world, and then up into the cloud as well. So in order to address all of this, like if you want to do digitalization, you have to address sort of this basic characteristic, and this sits below the level of all the advanced applications and the great stuff that you can do in the cloud with, you know, artificial intelligence and machine learning, and the dashboarding that you do for the business, and also for just even maintenance and operations sitting below. So all those advanced applications that do great things with the data, they have to actually be taken care of. Now, before we continue on with sort of the concept of, you know, how the UODL, or the Unified OT Data Layer, will work, or what the idea behind that is, maybe we'll do a quick survey, and if could cue that up, and just to see, you know, where you guys are at in your journey, right? So you're somewhere along that spectrum of not at all, haven't started yet, or not considering it, to yes, already implemented it. So if you can, I'll give you a few moments, take a look and see sort of where you're at, and we'll see how that goes.
So, Derek, Mark here, when you work with customers, what would you usually see among the options here?
Right. So a lot of times it's almost like a kind of step by step. The majority are in the early stages where they're starting off from some starting point, let's say. There are some that actually are already, they have they were early on, they identified a business need for how they would utilize, let's say, the cloud. So that ultimately, it doesn't mean that digitalization ultimately means being in the cloud. They could also use it in the business layer, but there are some that already identified that they need access to either the AI or the larger analytics, and they figured that piece out, and therefore they worked hard to get at it. So they might be there, but the majority of people are actually either in POC space, or taking their first steps to actually get onto, let's say, a common technology for communicating before they go on.
Great. So the audience here seems to be largely investigating options at this point.
Yeah, yeah. And that's okay, great. Yeah. And that's so, yeah, looking at the majority. So, yeah, most people here, if it was on a bell curve, that I guess would be towards the middle. That would be the norm, right? Where people are looking at how they could proceed. And I'll cover some of this as far as the questions that people have about how to get started, given that they already have existing infrastructure. One of the first things that people bring up is, well, I've already got stuff deployed. I can't just replace it, and it doesn't have capability X, Y, or Z. So how do I start? Anyways, that's what we'll get into here.
Great. Well, thanks for involving the audience.
Yeah, great to get the feedback. All right, guys. So I'll take one more sort of before I again dive into some of the aspects of that digitalization. I'll just talk about some of the maybe hidden benefits or the values of the concept of what a UODL, a Unified OT Data Layer, is. Okay, so if we look back at how systems normally evolve, what you'll find is that you've got various sources, a lot of times, of course, third-party systems. Some are proprietary, some are open standards, but they might not be compatible between each other, even though they're open standards, and some are fully compatible. So you've got various types of raw data that are coming from various data sources. And over time, in a lot of companies, what happens is people use an application. Let's say they start off with an advanced application, whether that's a historian or an analytics package, and they gather the information there, and that ends up not only doing the analysis or the advanced application portion that it was designed for, but they also start using it as sort of the launch point or the access point for other applications to get data so they can then do something with it. So it kind of sits in between. Now, in an organic way, of course, that served its purpose, but as you start to accelerate and as you start to try to digitalize, that also starts to become a bit of a barrier, because now those other applications, A, have to be compatible with that particular application, and B, that might be expensive, because depending on how access to your data is monetized by that company, that also might become a bit of a barrier. So the idea is that if you bring in a way to access information in a common format. Now, as Mark introduced me, I do a lot with OPC UA, so I quite strongly believe in that method of accessing information. It's not the only way, but it's a very pragmatic way, stable way to access that information. So if you bring in something that's, let's say, based on OPC UA, a very common standard, right? And let's start calling that a unified OT data layer, even though there's more to it than just using OPC UA. But anyways, when you bring that in, and that acts as the common way of accessing information from the shop floor, now what happens is, rather than being the advanced application that was shown there in red, rather than it being a layer that everything has to go through to basically talk to the rest of the system, now it can also, now technically you could show this, that application still can talk to the components as it did before, but it also could just become one of the users of the data that's facilitated by a common layer. What that does is it provides a common way for all applications to access the information, so you don't have to necessarily access again, the information one way through the advanced application and another way for the other one. So you have a common access point, and that means fewer connections to the underlying sources, because now you are connecting to that UODL, something that facilitates the UODL. Now, moving one step further, and you see that the raw sources are still shown partially through the main block, more than just direct pass-through to the underlying sources, the unified OT data layer also provides views into the data. Because one thing that, again, we've seen time and again with customers who are, for example, talking in the cloud and using the data lakes or data oceans in many cases, is that you need that data to be meaningful. It's well-wishing to say that AI is going to figure out what the data means just by looking at it, but that really is a lot of work and perhaps more work than it's worth. So it's a lot better to actually cast the information into the view that you want to have of it, whatever the structure it has, whatever the units are, as close to the source as possible. So you have as little abstraction as possible later on, which then has to map all the way back down to what's happening on the shop floor. So the UODL, in order to be really useful, it needs to also facilitate that, to say you get access to the underlying components, whatever they are, but you also can dynamically bring in different models or create the ones that you need, and then present views to that information using through the model. So each application, technically, if it required its own structure, its own way of taking that data in, you could actually make mappings so that they can all access that information in their way, even though they're using a common layer, right? So there are many more aspects, and hence the title of the presentation, the 5 essentials. They're actually, those are the top 5 that we will cover, but there are many things that play into just creating this UODL. And the idea is to be holistic. So on this slide, I've sort of expanded that. Those are the icons I used at the start of the presentation. So when you look at the UODL, these are concepts that need to be integrated. So kind of like when, back in I'll age myself, but when we were, in first early years of university or high school, and we got our first cars, and you got your stereo systems, and you would buy all these components, right? You'd buy the amplifier, the preamplifier, and then this, and then the equalizer, and try to stitch it all together. And I mean, it all worked, but if you could afford the better system that actually would have everything integrated in digital, you could choose what you wanted it to do and the behavior of how the speakers responded, whatever. I mean, that integration, that holistic approach to all that information was, or to the functionality, was way more useful. And the same way with this, if you take these different aspects, you can always patch together various components and try to build up these capabilities so they cover what you need. But if you have a system that is inherently built to support or address all this type of functionality, it doesn't mean you have to use all the functionality at the same time or at once, but as your needs grow, it has that capability to support that type of functionality. And that's sort of where the magic happens, where you're creating the potential for doing all of this, even though you don't need to convert it into current activity, right? So you could go at different rates. But anyhow, all that brought together, the connectivity, the consolidation of data, or basically, call it on aggregation or federation, the contextualization of that information, and that's whether you're preserving it or you're enhancing it. Collaboration, which is basically just sharing information with everybody in the enterprise or to the cloud, and then the actual cloud access itself, the integration. So currently, that's sort of the shell explanation of what UODL provides for all the applications. Okay, so let's go to the first one. Out of those 5 verticals that I showed, let's start off with the data connectivity point. That's where the story usually begins. And when we go back to the network level then, or the enterprise view, let's start at the bottom there, where we're trying to communicate to the different data sources and also to start to bring them together. But connectivity comes in first. And again, what that does is it creates this, to look at another way, the UODL represents all the things that you have throughout your operations. And then, for example, the IT layer accesses that information without necessarily having to talk to the components that exist within the network down below, because it can actually talk to the UODL to fetch the information that's required. So you're already kind of building a conceptual separation between the two, even though they're integrated. Okay, now in this case, when I talk about the connectivity, OPC UA is the underlying mechanism, and I'll talk about that a little bit more, especially as we get into things like modeling and such, because again, it's kind of nice when you have a standard that actually tracks along with, let's say, these concepts, so it already supports it anyways. It's just a question of converting into that capability. Before I go on and explain how that's done, I think let's do one more survey. And I'm curious, since everybody's here and you guys are investigating and looking at it, regardless of where you are at in your digitalization space, how much OPC UA do you guys use? So maybe I'll just give you guys a few moments. And again, it'll be curious to see how this, let's say, aligns with what we see, since we deal with it day in, day out.
Derek, because OPC UA is so pervasive, could it be sometimes people may be using it and don't know?
Definitely the end users, absolutely. Or even, I mean, IT is also becoming much more aware now than they used to be of, what happens in the OT side. But definitely end users may not be aware. They might notice that they get their data more reliably, but yeah, you're right. They might not know. But people who are on the OT side, I think they would probably be aware.
Certainly. Oh, nice to see some results coming in.
Yeah. Okay. And I mean, if I look at this curve, so yeah, actually it's still changing. It's like watching a game. It's like a racehorse. which group's ahead? Yeah. Okay. So yeah, so what I'm seeing, what breaks out here, it looks like the largest group is in the phase migration. So basically, you're starting to see components, and this is actually exactly what we're seeing in the marketplace too. I mean, we could see it through either our sales, because Matricon, I mean, we deal with OPC Classic, we deal with OPC UA, and we're definitely seeing an upturn in the OPC UA side. But that's not to say Classic has disappeared. It has got a massive 20-year install base, so they're definitely there. But this kind of curve where some people have standardized on it, we work with oil companies that exclusively will now use OPC UA, and they will not accept anything new that comes in otherwise. And then there are, of course, the phased migrations and such. It's good, at least we're reaching some more people. So some of the people on here also are just asking, what is OPC UA? Which, hey, that's great. Now you've heard about it. It's welcome to a great new era of connectivity. It's basically an open standard for connectivity, but it does a lot more than just connecting. It has to do with data defining what the structure of the data is and ensuring that it's secure and all that sort of nicely packaged and independent of operating systems and such. So it's
thanks for sharing. Thanks for sharing this results.
Great. Yeah. Okay. So, all right. So let's continue on. So OPC UA, and this, by the way, is the logo that's used by the OPC Foundation. So this is the OPC UA. If you see that symbol, now you're dealing with OPC UA. And that's what when we build, for example, what we call data technology to implement the unified OT data layer, that's what we based our solution on. So in our case, it's called Matricon Data Broker, and I'll talk about some of it a little bit. All right. So when, for example, we're implementing it, if you take a data broker and you use adapters, which would convert. So number one, for the connectivity to happen to an end device, you have to talk the protocol, whatever that device is. That doesn't go away. So if at all you want to be able to mention phased migrations, well, the first thing is you need to do is make sure that you can talk to the actual native systems that you have in place. Now, the nice thing about using EODL or something that implements it, in this case we call Data Broker, is that it will talk a particular protocol, let's say Modbus, the simplest, sort of protocol, and also the most widely used, if you look at just how long it's been around and how many applications it has. But the thing is, it lacks all sorts of everything from timestamps to engineering units and just contextual relationship between the different items. They're just registers, basically. But if you bring that in, where you talk the registers, but you bring it into a UA address space, now what happens is you can start grouping that information and putting some structure around it. And therefore, everybody who wants to get the information coming from that particular Modbus device now no longer needs to even know Modbus, obviously, and doesn't have to work with the registers because that maps into symbols or items, names, which they can address directly, and those can even be part of a structure, so you understand what the overall structure of whatever you're working with. So if you're talking to a conveyor belt system and you've got controllers running the motors, and you got some sensors that are looking at the status of the motors, and you got some sorting arms, or, various components that you would normally see along the line, what happens is you can group that information, and you could say, well, for a conveyor belt, I've got a motor, and I've got some sensors for it, and the temperature sensors, and velocity, and etc. You can group that information together. So applications that come in from the top and want to see what's happening with that part of the warehouse or the plant, now they're not poking at registers, they're talking about a particular conveyor and particular aspect of it, right, or a motor, and then drilling down. Not everybody will want to do that, but again, the maintenance guys will have one interest. People who want to know in operations of whether the products are coming through and how many have come through that day or that hour or whatever, they also get their information without having to worry or being tied down to the exact information coming from the source. So again, from to get the gears going there, thinking about phase migration, it doesn't necessarily mean migrating and getting rid of your underlying data sources. It's migrating to start using the data in a richer sense, even though you're still keeping the stuff that sits below. An advantage of that is that not only are you extending the functional life of your asset, because now it continues to do the job that it's done, because let's say it's still working, but now what you can do is also have that tied in to into a broader information space, so the rest of the company can utilize it in a more modern way of what they're trying to do. All right, so anyways, these things we just plug in, and that's how you start to gain access. Now, that is connectivity. If you want, for example, if you're using Matricon Data Broker, well, then we would use an adapter, which does that conversion, puts it into a UA address space in Data Broker. At the same time, you might have classic systems. So maybe all you do is you're just converting from classic to OPC UA, and then you're just connecting it and you're federating it, for example. So it doesn't mean everything has to have an adapter that would talk to it, but you either are talking OPC UA or you're getting into the OPC UA space so that the rest can happen. You can take advantage of the rest of let's say the functionality. Now here, I just wanted to show you guys a bit of a shift. So what we're seeing is, for example, if we look at a classic, these are, let's say it's a Matricon solution in a classic way that we used to provide it, and how that would look, let's say better, right, going left to right, as far as making it more modernized. If you're living in the classic world and you've got a classic server, which then you have to convert into, for example, UA, because at least you want to have some better security, and you got different components. Maybe you have an odd UA server that's already there. Again, most people are phase migrating UA into their systems. And then you've got a UA client, and then eventually you'd also, going up top, would like to talk out to the cloud, or you got something that sits outside the firewall. Questions start to come up where, how do you actually walk through all that? Like, how do you move that information through? And I've got some call outs there to say, some of the limitations. It doesn't mean that that's quote unquote bad. I mean, people have been doing this for 20 years now. But at the same time, if you want to shift gears and start to be, moving in a more modern direction, if you start using, for example, adapters, or you get things into that UA address space and then you go forward, now you're able to traverse the network, work across firewalls, and I'll talk about the security aspect, why that is more secure. You can remotely configure it. You can use a single configuration in order to set up how you talk to the overall layer, as opposed to individually having to configure all the different components. So the advantages of shifting to something that can incorporate or can instantiate this UA, the unified OT data layer, the advantages are pretty clear. You get the connectivity. You also make it more sustainable. You need fewer components, obviously, as you shift away from classic, because you don't need the conversion in between, and you get more freedom to move across the network. Okay, so that's the connectivity side. Now, moving on, let's talk about context management. And the reason the data context is so important is, if you want to do more with your data, you want to make sure that the systems and the people, but the systems that are using the data can actually have a chance to to understand what the information is. So in this diagram, what I did is I showed, let's start off with data with no context. Let's say we're finding a robot, the most common kind of thing that we show in cyber stuff, right? So, or the IoT world, right? It's modern. So you've got data without context. I show it as gray boxes. It's basically values. Data, you don't know what the meaning of them is. It's just values. Now, if you move up a little bit and you look at data with units above that, now you got colored squares. So at least you start to recognize that there's some relationship. They represent the same things because you can differentiate. That's already context. But now to really start to understand that you're looking at the robot, if you can also structure those pieces of data to say, not only do you know what type of data it is, but how it relates to each other, this is where basically fundamentally you're building a digital twin, something that lets you represent the key characteristics of your physical system, but in a cyberspace, right? So we call it CPS, cyber physical systems. And that's, at least that's in Europe when you're dealing with Industry 4.0. That's how they refer to them, the CPS, the cyber physical system. So eventually when you're using these, the advanced applications, they can now simulate, they can display what's happening with the system because they have a picture or at least a notion of what that data represents. So in order to get to this stage, if we're talking in this slide now, if we're talking still about the actual values that are coming in and they don't have the context, like we said with Modbus, or they have some context, but they're organized in different ways. The thing is, if you want to make that part of the more modern digital twin type of era, IoT and all that good stuff, on the right side, you need some way to upgrade that information. So again, I'm using, throughout this presentation, I'm using Matricon Data Broker as that data technology used to build a UODL, the Unified OT Data Layer. And again, since it's based on OPC UA, we're using companion specifications, which is a standardized way of representing various types of information models in a consistent way so that all clients, UA clients and servers can exchange information, understanding what it is that they're talking about, or at least representing it that way. So above it there, I showed there's a little map there. I'm not expecting you guys to be able to see each logo there, but there are a lot of organizations that are working together in each industry to define specific ways of how you, for example, model a valve so that everybody talks about a valve in the same way. Because one of the plus in technology, there's always a plus and a minus. The plus of OPC UA information modeling is now you can model. The potential downside, if you don't do it in some kind of coherent way, is that you go from the late 1990s connectivity wars where everybody had their own protocol for communicating. You now open up the era of modeling wars where everybody creates their own frameworks and their own way of defining the data, and now how do you actually make those make sense between each other? So the nice thing is if in industry you start to standardize on certain ways of expressing what that each piece of equipment does or how you refer to it, of course that creates a uniform space. So anyways, that's the work that's going on, and there's a lot more to happen there. There's also things like harmonization, which is saying between groups, even though in an industry you identify how you specify a model, then there's a question of, okay, but now between them, if they're describing the same characteristic, then maybe there should be a harmonization in how you do it. So there's a lot more work that happens there, and it's ongoing. But the nice thing is whether you're using something that's already defined or even making your own, Data Broker will allow you to bring in that model in a standardized way on its own yourself. You can then map the information from the stuff that's coming from the left using its own structure or no structure and context into something that pops out on the right, which says anybody who now connects to Data Broker starts off with the organized view, and hence, eventually the digital twin or whatever else you're using on that side. So the dynamic ability to upgrade the information rather than being stuck with whatever a vendor happened to put into the product that they say this is how it's modeled, gives you that freedom to adjust whatever that product is or the data coming in to actually fit your application or whatever you've got set up on site. Okay. Now, the other thing about being able to do that, about being able to bring in to do the modeling, is that you also need to be able to map it. And mapping has to do with how you attach, you create a structure, but now you have to attach the real world data to that structure when you instantiate to say, okay, now I've got a conveyor belt system, like we said. So conveyor belt system 1, I want that to talk to specific PLCs on that particular line. or whatever sensors you've got. So you have to be able to map the physical data that's coming in or the protocols to specific items in your model. So you either do that just to facilitate kind of controller to controller communications. So one PLC doesn't talk to another. This acts as kind of a bridge between them. Or you're taking in the center box there, the context enhancement, you're taking flat data, you're adding some context to it. So you're mapping it so that now there's engineering units and whatever else you add into it. Or you're doing contextual translation where a vendor provides a model and you're going to remap it into another view because a particular application needs it that way to optimally use that data. And you do that again as close as you can to the source, ideally, so that again, if you make any changes at the source, that translates very quickly so the largest amount of users going above that source have the same common view for the mapping. So you stay in sync with what's actually happening on the shop floor. All right, so just a final kind of, to show that then, in Data Broker, when you bring in the companion specification shown on the right, then when the data comes from various sources, whether they are UA or classic and converted into UA, it generates the view of that model. So when a client connects, while you could drill down and say, I want to see the base data that came in the raw data, you actually also have the option of, when you're browsing the space, to say, well, I'd just like to take a look at the robot, right? I don't need to know each individual servo controller and all that. So that's the point about mapping. It's a huge, important topic. People are relatively new to it still, and it doesn't have to be extremely complex. It could be as simple as just adding engineering units, or it could be quite complex to create digital twins. All right, moving on. Number 3, network traversal. So again, the idea here is that if you're going to communicate across the enterprise and you go on the shop floor or you're going between the business unit and such, the key thing you need to be able to do is security talk across firewalls. Now, the way you do that is, of course, encrypting data and such, that's just what happens with the data. But the question is, what do you do with a firewall? Because in a traditional sense, when you have a client that needs to talk to a server, well, the client initiates the communication, which means you're talking down, right? And that means you have to open up an inbound port because the client calls the server. It's kind of like a master-slave relationship. But what happens is OPC UA has what we call reverse connect, which allows you to actually have the server call out from behind the firewall to a particular client. They still have to go through all the handshaking and certificate exchange and all that. So trust is established the same way. But the point is, whoever's designing the system in the more secure area, which is typically behind the firewall, of course, it calls out the client, and then that connection that was established is used by the client to continue the secure communications with it. So that's a UA concept. Now, if OPC components have that, then they can just directly do it. They don't need any additional components. But if they don't, because a lot of OPC UA products still don't implement the full spec and they don't implement reverse connect, again, if we use Data Broker, it sits on each side, it can facilitate doing that. So in order to maintain the idea of a UODL, the Unified OT Data Layer, you need to be able to enable this connectivity in a secure way. So that's where if you use this component, it can augment it, and therefore even a UA server that doesn't have that capability will still allow the reverse connection to happen. Now that expands a little further. In reality, especially when people are doing phase migrations, you've got classic, you've got OPC UA, so how do you bring all those together? So number one, we know you have to use something like UA Tunneler, which is a product that basically converts classic to UA, because you're definitely trying to get off of the classic side. Not necessarily you don't have to replace the component, but you want to stop using it. So number one, you don't want to use the native OPC classic way, which is using DCOM, very not secure, not good, right? Now, if you use Tunneler, it removes the DCOM side, but in order to communicate across the firewall, you still have to open up the inbound port because it still behaves like a client server in a traditional sense. If you bring in Data Broker, now what happens is even your classic components can actually use UA's reverse connect functionality, because when it's converted to UA, it can still do the reverse connect using Data Broker, and your two classic components can still actually take advantage of the modern way of talking across the network, which is using reverse connect, and that again is inherently part of the UODL. So you can see how these various benefits that you get of individual pieces of the technology you can combine them all. And if you have a system that incorporates everything into one, regardless of what component you're starting with, it actually allows you to continue to use that component and yet get the benefit. Okay, number 4, data federation. Not so much to say here. I mean, obviously, if we're creating a unified OT data layer and we want to give people access to the entire layer, then, for example, IT talking down, and really what we want to do is for that UODL, we want it to have access to the UA data sources, classic data sources. You might have proprietary stuff that needs to get converted or other. And basically, there's a conversion that happens between them into a UA space, and then that provides the springboard where your other clients coming from above connect basically to this single layer. So the federation part is pretty easy to understand. You're rolling all of it up, but now you can understand how even though your existing systems might not talk UA, they can still take part in this, and therefore you're extending their life, functional life, and you're able to do the phase migration. Okay, and finally, for cloud integration, in order to be able to get the information from your edge, from the edge, right? So normally when we talk about, what we define as the edge, typically for industrials, unlike cloud companies, they have a different view of the edge, but for industrials, we say, well, it's on premises and it's before you talk out to the cloud. That's what we call the edge. So basically you go through the different firewalls, you might go into the business network, and now you want to talk out to the cloud. A very convenient way to do that is by using MQTT. Now there's a number of things there, and it's a whole other conversation as far as, some people are confused and they say, well, it's MQTT versus OPC UA. Doesn't have to be that way. MQTT is a transport. OPC UA can use the transport. So whether you're doing pure MQTT, which is just sending values over that transport, or you're doing OPC UA over MQTT, the point is MQTT is well designed, well suited for edge to cloud communications. It's publishing it out. It works great in that direction. So anyways, what we do is you need the UODL to be able to talk to cloud providers. Now, obviously, at the time we also implemented, we were working with the Google Cloud. That's obviously going away, being phased out, but AWS and Microsoft Azure continue on. So you can either do it directly by talking MQTT, and they will have brokers that will listen for the data. But again, all the information that we federated, and you can have multiple levels as shown in this diagram, where you've got different data brokers or different levels that are doing different levels of federating. But eventually, use an extension like MQTT Publisher, which basically lets you take UA data, say, this is the data I want published, bang, it goes out. Again, you have to have some setup because there's security handshakes and such even there, and they're a little different on how you work with stuff for Azure or for AWS. It does it both, but that's one way. And then the other way to do the integration is to actually use the tools that cloud providers provide, right? So if you're using Microsoft, if you're using Azure, then you'll have IoT Hub. You'll be familiar with IoT Central, which are increasingly advanced ways of working with, let's say, your edge data in the cloud. And then on premises, you might have IoT, actually it's a UA Publisher, but it does the publishing out, and they talk their own secure way out to the cloud. But what happens is that even that component then actually just uses the data, in this case, Matricon Data Broker, but the UODL, it just has to access the UODL. So you don't need the cloud providers to get access all the way down to your shop floor. What they do is they access the unified OT data layer, and from there, the information gets out to the cloud. So again, you're isolating and removing the need for them to actually have to go through your nested networks down below just to get to the OT data. This is actually something we did. Last year I was at Hanover Fair. We made a demo, work with Microsoft in their booth. We actually did a bidirectional communication from actually the trade show floor, talking to the cloud and controlling kind of a small simulator of a 3D printer. So that worked well. But anyways, that's the type of thing that you can do for, let's say, the easy integration with cloud, and regardless of which cloud vendor you're dealing with. All right, so to wrap this up, basically we've now traversed all these different points, from all the way at the bottom to walking through the network to adding the data, the context to the data, and then getting it from there out into the cloud. So that, in summary, is what the whole point of a unified OT data layer is. And I think that this makes it much easier for your journey as you phase in the new technologies. It allows you to aim and start taking advantage of the full, let's say, benefits of modern working with a modern OT data access. Okay, so that's it.
Well, thanks very much, Derek. Now our presenter will answer questions from the audience. Please type your questions for Derek in the Ask a Question box on the screen. We will get to as many questions as time allows. Questions that we don't have time to get to today will be posted online with the archive version of the webcast. Remember to download a certificate of completion and a copy of the presentation by using the Event Resources tab on the left side of the screen. Now we'll go to the questions, and please continue to submit those as we go through the answers. First one, we have a relatively small setup with just a few PLCs and sensors. Would a unified OT data layer still be helpful for us?
Oh, great. Yeah. So the answer is yes, absolutely. It actually doesn't matter how many you have. So even if you've only got a single PLC and you're working with it, depending on how you're going to grow, so whether you want to have more security or you want to make that system more sustainable, someone still has to figure out what are the registers, how are you working with them, how do you make the data available outwards. So if you have also during our survey answered that you are looking at digitalizing your business, that means someone even higher up in that chain will be also trying to work with that information. That means at some point you're crossing out of your OT space, and that data has to start to be available to people outside of OT. So again, you don't necessarily have to use every single feature I just described, but you'll notice that very quickly you actually do need little pieces of it in order to facilitate what you're doing. So yes, you could, it would still help. It's a concept. It's not a thing. You don't buy a UODL, you implement a UODL. It's a way of thinking about how you organize it. Good question, though. That's great.
Good. Is this technology primarily meant for cloud applications?
Okay. So yeah, that's the last topic that I touched on, which was the cloud. But no, actually, it's the whole journey, right? So it's whether you're working down on the shop floor or you're facilitating access on-prem to business or you're talking to cloud. That is just one of the aspects, and that's how come we talked about the 5 essentials. So no, it's not just for cloud, but it definitely works with cloud applications.
Good. Let's see, another question here. How does the technology make our systems more secure? I thought OPC-UA is already secure.
Yeah, that's really good. So yeah, the OPC-UA absolutely is secure, or as secure as practically can make it. Obviously, it's an ongoing evolution all the time, but it is secure. The question, though, is kind of like, think if you're building your house and you buy a secure lock, or you're using secure locks, but are you locking the doors? Is the design of the house such that you can't break in through a window and get in there? There's many aspects to security, not just a particular component. So the standard itself is one thing. How it is implemented in the product and how the different patchwork of products work together in order to provide the wholesome sort of security or whatever functionality they're meant to do, that's where the UODL is an application of OPC-UA as the foundation to service and enterprise. Maybe I can put it that way. So the two are actually related. One builds on the other and uses its secure capability.
Good. Does using a unified data layer, OT data layer architecture replace the need for a historian?
Depends what you're trying to do. I mean, if you're primarily using a historian just to access your real-time data, or you're working with the sources, maybe. But I think the point more so is to enable broader, secure, uniform access. I think if you've already got an application where you're happy with using whatever comes off that historian, it is not meant as a replacement. Whether you choose to do something else, well, that's up to you, or you're moving to cloud or whatever else that you're doing. But no, it's not a replacement. It's at least an augmentation of how you access the data, maybe in other ways, or the historian just fits into the UODL as well, It's just a component in your system.
Good. Can an MDB, and maybe explain the acronym, be deployed in a cloud Linux environment?
So you're probably referring to the Matricon data broker. So maybe you've already talked to us, but yeah, so Matricon data broker is the software that we make. We call it data technology. And by the way, DT or data technology, just to add something there, it stands where it sits. If you look at the OT and or the IT and the OT, the two boxes that are usually shown on top of each other, we always talk about an IT OT gap. So data technology, DT, is something that would sit as a cube kind of in between IT and OT, and it's specifically meant for addressing all the things that we talked here. So software that acts as data technology would aim to fill, to overcome that IT OT gap, and Data Broker is that type of technology. So is it deployed in, it doesn't matter where you deploy it. So you can deploy it in the cloud, you can deploy it as a Linux container on premises, or like I said, in the cloud. It can run on Windows or Linux. So it's fully open. Like, one of the good things about OPC UA is it's also no longer tied just, for example, to Windows. So this works everywhere.
Good. How can we convince IT that the OT network can be secured even with outside groups providing remote services and system upgrades?
Sure. So that's a lot to unpack in that one. Number one, the convincing side, as far as the merits of securely accessing data, so number one, there's the fact that it's OPC UA based, that addresses certain fundamental questions of, is the data encrypted, protected so others can look at it, is the trust established between different components, etc. Now, building on top of that, though, if, for example, you're using things like reverse connect, then what you're doing is, you're maintaining control of who gets to connect if it's going to come in from the outside. Number two, there are different ways to share that information out. As I showed, you can, for example, use MQTT to publish data out. So it's not just that you have to have a direct client server connection. You can actually publish data out, and therefore, if they're just consuming the data in order to provide their service, well, then there's basically no risk there, as long as you're willing to share your data with them. If you are in a situation where you need them to actually have access to your system and have, for example, bidirectional communications, then you really would have to look at the use case. But at least what I can say is that you can control how the connection, who gets to connect to what and when, and then when they are connected, what they're allowed to do as they're connected. So that is something that we're using best practices. So reverse connect, by the way, of talking across a firewall without opening up the inbound ports on that firewall, that is a best practice in the IT space. So when we deal with customers, we give a presentation about enterprise connectivity, and we get to the firewalls and the DMZs, and we start describing the reverse connect. A lot of times, actually, that's when the IT guys perk up and go, "Oh, I like that," because that's the way they do it. That's how you security work across the firewall. So that's, I guess, without knowing more, that's the best solution I can give you there. Okay, let's move on.
Great. A lot of great questions coming in. Again, please continue to submit, and we'll get to as many as time allows and try to answer them offline if we don't get to them all. Skipping down a few, why is OPC UA connectivity better than MQTT? Or is it?
I think that's again, a bit of a loaded question, and it depends which angle or what your experience is or what is it that you're trying to do. As far as a broad system-wide connectivity, they have, first of all, so OPC UA, it can be used in applications, or it's more versatile, let's say, for uses within, when you're dealing with on-prem or the OT networks where you're working with. There's a lot of benefits that you get out of there, as far as the standardization of how clients and servers can understand the structure of the data that they're working with. Typically, they're working on a LAN. When you're talking out to cloud, so when you're bringing data in from the field, right, which is where MQTT started off. So you got sensors, or you got RTUs, and you're feeding data back. Very good at bringing that information in. And as I stated, I mean, when you're talking even to the cloud, kind of in that direction, an open WAN type communications, great. Now, again, as far as choosing what you're going to use, you really would have to look closely at what your end goal down in the future will be, because OPC UA travels over MQTT just as well. MQTT is a transport. And for people who don't live in the protocol world, or kind of at that level of protocols rather than applications that sit above them, that's sometimes confusing. But a protocol travels over a transport. So MQTT itself doesn't care what type of data it transports. It just transports data. And you can define things like JSON structures and whichever. But kind of like XML, everybody can define their own structure. And therefore, you have to have something that can decode that structure. Now, you can bring in additional frameworks on top of MQTT, but then now you're building up a stack on your own. And the question is, what is the rest of the market doing, or at least the part that's relevant to you? OPC UA provides a common base where the market there's a huge penetration for what OPC UA does. It's well adapted to on-prem and remote communications, and it's just a question of which transport you want. So you'd have to look more, not just on which transport, but what overall system you want for the security, the modeling, the scalability. Both have very good, but there's a lot of factors to look at. So it's not such a simple thing to say this is better than that, because you're not really comparing apples to apples there.
Sure. Yeah.
That's another webcast, so I'll
Good. Well, maybe we'll get a chance to do that one too. So what could be the main or the differences between data broker software and a data gateway device? So kind of a hardware software question.
Sure. So yeah, and that it's interesting in this, like in all technology verticals, I guess, you overload terms all the time, right? As far as what does it mean? So when we talk about gateways or brokers, I mean, technically, the data broker software can actually run on a gateway machine. If you're defining gateway as the hardware that's going to be, whatever you're using, Dell or whatever gateway you have, well, whatever software you put on there to actually work with the data that it's supposed to be consolidating and releasing outwards, that's the software that could run on there. So we'd be more than happy, if you're a vendor and you're making gateways, to OEM MDB to you, and you can put that on, and your gateway can now actually facilitate a data layer. So the two they don't necessarily conflict with each other. It just depends where you want to use it. Just so you know where it can run, for example, Data Broker can run as a container. It's containerized. You can deploy it from Azure, or you could install it on premises, again, Linux, whichever. So whichever environment you're working with, if you're designating a piece of hardware to be a gateway, well, then you could run it there, or whatever else you're going to use. Depends on your need. Okay.
Great. So we have time for maybe one more question. If we didn't get to your question, don't fret. We'll try to do that offline, and please continue to submit until the webcast closes. We'll get to them all offline. So here's one. Where does an MES system sit in relation to the unified OT data layer?
Yeah, so MES typically, so you'll be up, that's in the higher, I mean, you're looking at the execution, right? You're managing what's going to happen when, you're coordinating, with all the execution. So that would sit, I would say, let's say above it, or sort of, I mean, it could be in the space. You could still have it running on the OT network, but the key part there is that when you're trying to access the data that's being generated off your shop floor, if there's anything that needs to come back, or you're trying to send information to the shop floor, because that's how you're sending the orders for, you're going to change the color of the product, or you're launching another line, or whatever the scheduling is there, it allows basically the MES to interact with components in the OT network, as long as obviously it talks OPC UA or one of the protocols that, for example, Data Broker could talk, if that's what you're using. So it's just a component that works with it, but it's not the facilitator. You wouldn't use an MES. Its job is to identify what you're going to do when, and keep tabs of what all that is doing, whereas the unified OT data layer is sort of how you interact with your environment, production environment, and everything that you've got in it.
Well, thanks, everyone, for the great questions. And thanks again to our great speaker, Derek Kamenek, for sharing his time and expertise. I'd also like to extend a special thanks to our sponsor, Matricon, for sponsoring today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use the information to improve our webcasts. Finally, on behalf of Control Engineering and Matricon, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.